Something massive is forming in the Sahara Desert that can destroy our entire planet. What is that? And why are scientists worried about this formation? Hi guys, and welcome back to Not Alone. The weather pattern over Europe has been unusually stable and extremely dry since the end of the cold season, with strong upper highs and ridges remaining over the continent. The pattern will change in the coming days as a deep trough emerges from the north, boosting the jet stream and shifting it to the southwest. Recently, new satellite images have revealed the scale of the vast Saharan dust cloud that has blanketed Western Europe. Storm Celia is transporting a warm, dusty air mass from North Africa to Europe, affecting air quality in several countries. Spain was particularly hard hit, with local officials advising residents to wear masks and avoid outdoor exercise. Those who suffer from allergies or respiratory problems are especially vulnerable to spikes in small particles of air pollution. Although harmful to human health, dust clouds transport nutrient-rich minerals from the Sahara, the world's largest and hottest desert, to ocean life and vegetation. Sand and dust storms occur on an annual basis when strong, hot winds sweep across loose soils on arid land. In the summer of 2020, a massive dust storm known as Godzilla swept nearly 24 tons of dust from the Sahara to North and South America. The dust cloud was so large that astronauts from the International Space Station tweeted photos of it. After Godzilla took off, NASA studied the plumes using satellite data and computer modeling. While dust clouds will continue to vary from year to year, scientists predict that due to climate-driven ocean heating, plumes will be the smallest in 20,000 years this century. This is due to the fact that sea surface temperatures have a direct effect on wind speeds. If the northern Atlantic Ocean warms, trade winds will weaken and carry less desert dust. Because of the weaker winds, tropical rain bands can more easily move into desert regions, keeping the sand damp and less likely to be blown away. And this Saharan dust cloud will move along the increasing southwesterly high-level winds between the northerly trough and the persistent blocking high to its south. The formation of this general weather pattern across Europe indicates a lower geopotential height to the west and high pressure across the European continent's east and south. This means that the air mass will be brought directly from the Sahara Desert by this weather pattern. The direction of upper-level winds frequently increases the possibility of massive dust cloud particles spreading far north into Europe. We saw something similar on March 15th, when a massive amount of dust covered the snow across the Pyrenees mountain range. That event dumped a massive amount of Saharan dust across the Iberian Peninsula and parts of the western Mediterranean. Very high, even historic dust concentrations turned skies and snow into orange, desert-like scenery. Over the Pyrenees Mountains, some of the scenes appeared to be apocalyptic. The forecast amounts of Saharan dust are expected to be very high and spread across a large portion of Europe. The Sahara Desert is the world's largest and most famous subtropical desert, but knowledge of it is surprisingly limited. Estimates of when it formed range from more than 5 million years ago to thousands of years ago. Geologists studying wind-borne Saharan dust on the Canary Islands have come closer to determining its age. It's close to 5 million years old, they report. The Saharan dust cloud is named after the Sahara Desert, when the general wind direction in the upper part of our atmosphere is south-southwest to north-northeast. Dust particles can be carried far north into the southern, southwestern, and southeastern parts of the European continent. Often originating in the Algerian deserts, dust particles are sometimes carried even further north into eastern, western, or northern Europe. One reason for the uncertainty in the Sahara's age is that researchers estimate it using a variety of methods, including studying desert dust found in sediment beneath the Atlantic Ocean, analyzing sandstone, and modeling the ancient climate. To help settle the matter, geomorphologist Daniel Muse of the U.S. Geological Survey, lead author on the new study, and his colleagues examined sediment on the Spanish islands of Fuerteventura and Gran Canaria, where they discovered evidence of Saharan dust. The dust appeared in ancient soil layers, the age of which they determined based on fossils discovered in the same layers, and the age agreed with previous marine sediment studies. The findings were published in Paleogeography, Paleoclimatology, and Paleoecology in November. The Sahara is the world's largest source of airborne dust, and its journey does not end in the Canary Islands, which are located just off of Africa's western coast. According to Muse, it continues on to places like the Caribbean and the Amazon rainforest. Amazon soils are deficient in nutrients, and he believes the new findings demonstrate how nourishing dust from Africa could have supported the region's incredible biodiversity for millions of years, adding to the Amazon's own origin story. When a massive dust cloud event occurs in combination with a frontal system and falling rain, the dust is carried to the ground. Then we can see the dust deposited on objects and find an often thick layer of dust, dusty drops on the car or something similar. The skies will become very hazy and visibility will be greatly reduced. The formation of a massive dust cloud is sometimes associated with thunderstorm activity near or over desert areas in northern Africa. And the presence of strong winds blows the dust particles far downwind, usually north-northwest or north-northeast, towards Europe. Depending on the intensity of the jet stream, massive dust clouds could form and travel long distances, even across the Atlantic Ocean. Apart from gaseous pollutants, the Earth's atmosphere is also polluted by various particles. These particles, which can be in suspension, fluid, or solid state, have a diverse composition and size and are sometimes referred to as aerosols. These aerosols are frequently classified as floating dust, but they're better known as PM particles. PM stands for particulate matter. The aerodynamic diameter of these PM particles is typically used to classify them. The aerodynamic diameter of a dust particle is defined as the diameter of a sphere-shaped particle that behaves similarly to a dust particle in the atmosphere, which does not necessarily have a sphere shape. Particulate matter is the most serious of the air quality issues it could cause. Smaller dust clouds are part of a feedback loop that contributes to global warming. Particles in the air have the ability to reflect sunlight, so with fewer suspended, more sunlight and heat reach the ocean, causing it to warm even more. The satellite images were recently captured by the Copernicus Sentinel-3 satellites, which are part of the European Union's Earth Observation Program. We can easily see where the thickest layers of dust clouds were observed by looking at the different colors on the satellite image. We can also see how stable and cloudless the skies are over much of Western, Central, and Eastern Europe. This is due to extremely stable weather conditions caused by strong surface high-pressure systems, allowing air to descend and dry inside them. Indeed, as we have been experiencing very warm weather in recent days, it is also warming significantly. How is the weather in your area? Is it warm or dusty? Let us know in the comments. And if you like this video, don't forget to give it a thumbs up. See you in the next video, and take care.